So training your eyes to see what these limits are is a very, very helpful tool. You see one-sided limits of piecewise functions all the time throughout calculus, and it really is helpful to find a one-sided limit when you're looking at the graph of the function. But if you take the time to draw the graph of the function, which you might decide to do, and then you find the limits, then you run the risk of drawing the graph incorrectly and relying on the graph of the functions, the definition, to then find your limits. So you're kind of like, it's like almost like hearsay, like this person tells that person tells you, so you can't always trust that middleman. So I would urge you to not necessarily rely on the graph, but to try to train your eyes to see how to find the limits without the graph. So let's go ahead and get started. The limit as x approaches 0 from the right. So here's the way that I would like you to kind of try to take a look at this. X approaching 0 from the right. That means that x is greater than 0. So that's x is greater than 0. That's the little trick there. Oops, you couldn't see it. But the trick is to realize, oh, if x is approaching 0 from the right, that means that you're approaching 0 from values that are bigger than 0. 2, 1, 1/2, 1/3, 1/4, and so on. So if we're approaching 0 from the right, it's when x is greater than 0. And that's what we have right there. And we know that if we find the limit of a polynomial function, all we have to do is substitute in the value that x is approaching into the polynomial function, and we get 2 times 0, which is 0. So that's how we find a limit when we're not looking at the graph. On the other hand, if we want to find the limit as x approaches 0 from the left, if x is approaching 0 from the left-hand side, that means that the values of x are less than 0. So here x is less than 0. And maybe for the first little while you write that down, so then you can match this up with wherever you see that in the definition of our piecewise function. So therefore, we have x is approaching 0 from the left. That piece of the piecewise function is also a polynomial, so we get to just replace x with 0 because x is approaching 0. So the function is approaching 0 squared, but also 0. And so then, since the right and left-hand limits agree, therefore, the limit as x approaches 0 must also be the same number. But f of 0, that's the algebra problem. F of 0, it says when x is equal to 0, the y value is 3. So f of 0 has a value of 3.